the questions. If more questions, you send an email to Peter or an email to Dr. Möhringer. Or if you are interested in trying, I personally can give you some ideas, and I also could mention who is the expert in trying. Okay, we come to the next presentation. The next presenter is Katja Fruehwald-Koenig. She is professor at the University of Ostwestfalen-Lippe. She is a wood technologist. She has been engaged in palm timber research since many years, first with coconut and later with oil palm wood. Her university, and she is associated partner of Palmwood.net all the time, and she is at the moment she has organized and she leads together with Professor Rabenhaus, we will see him later, I think tomorrow, a huge project on oil palm trunk utilization for solid wood products and for biochemicals. So the sap for biochemicals, the fibers for other products. Okay, Katja will give us an insight into the palm wood properties, oil palm wood properties, which are very crucial from one point of view, which are very, very good, very excellent from the other point of view. And she will give us an insight from the point of view of an engineer, I guess. So what to do or what performance this engineering material has. Okay, Katja, the floor is yours. Katja?
Yeah, thank you very much for the introduction. I'm waiting for my presentation. I would like to ask technical colleague, because I've sent it to you because my internet is unstable at the moment.
You want to share from the our side that, or you are going to share by yourself?
I've sent an audio because I have the unstable internet at the moment.
Okay, okay. Munir, can you share the slide?
You got an MP4.
Yes, the 17 is there. Your slide is there. Yes.
It's 16, not 17. 16.
Yeah, sorry, 16. Yeah.
This one, right?
Yes, yes, that one.
No, these are the wrong one. Eco is the wrong one.
Eco is not. It's ID 16. This is not my presentation. Sorry for that.
By mistake, the properties of wild palm. Yeah, this one is yours.
Properties. Yeah, it's called properties.
This moment I can. I downloaded it in another computer. Just a moment. Munir, you able to do that one, Munir?
Yes. I can
please share the hard slide. It's slide number ID number 16 on the.
If it's a problem, I try to.
Yeah, it's no problem that we have your slide. We already find your slide.
Yeah, not only the slide. It would be better if we have the audio.
Yeah, audio also there.
It.
Yeah. Yes, Dr. Your slide is there.
Yeah, but still waiting for the audio.
Yeah, it's visible to me. I think visible to you also.
No, but there is an MP4 audio beneath the.
You want the audio first or that?
Yeah, I do it. I give the presentation.
Okay.
I try it with my presentation here.
Yeah, this one is the audio.
Yeah. So this is now, this should be mine.
Hmm.
One, sorry, I have to stop it.
Yeah, Munir, just make it full screen. Hmm.
No, it was mine.
Yes, yes, it's your slide. Munir, that's the right slide.
Perhaps you can give the slide, and then because I don't have enough internet at the moment, and then yeah.
Just make it the full screen.
Okay, thanks a lot. So sorry for the technical.
It's okay that
yeah.
because we are maybe not ready for that.
Yeah, no problem. So thank you very much for the introduction. Welcome to my presentation. My name is Katja Fruehwald-Koenig, and as Arno Fruehwald said, I'm working at Ostwestfalen-Lippe University of Arts. And since 2014, we are working with wood from coconut palms, and since 2015 with oil palm wood. Most projects were in cooperation with partners like palmwood net companies and or partners like FIDEC, FRIM, and the University of Hamburg. Today, our research group will present in various presentations some comprehensive results of this work. I begin with the properties of oil palm has explored the potential commercial uses for oil palm wood. In many cases, the wood can be used as a substitute for tropical hardwoods in panels like blockboards and cross-laminated timber and glue-laminated beams. Competitive products need material and engineering and, depending on the consideration of the physical, elasto-mechanical, and biological properties of oil palm wood. Especially product optimization requires the knowledge of the elasto-mechanical properties. Due to the anatomical structure, properties of oil palm wood, appropriate grading of the line in the production process. I will present more details on the grading of oil palm lumber later today. Next slide. Being monocotyledons, palms show a different in the anatomical structure compared to common wood species. Only lateral and no radial growth, no growth rings, wood rays and knots. The wood consists of lengthwise oriented vasculars embedded in parenchymatous ground tissue. The vascular bundles are composed of vessels and fiber cells formed in fiber caps with thick walls for structural stability. The density of the vascular bundle, the ground tissue, consists of thin cells and contains lots of water and sugars. Their density is low, and under load they thus, from the structural mechanics point of view, if vascular bundles are considered as reinforced and ground tissue as matrix, oil palm wood can be an unidirectional long fiber reinforced composite. Next slide. Next, thanks. The density, which is influencing various properties, declines over the trunk diameter from the to the center and also along the height of the trunk. The moisture content is very high and opposite to the density. Untitled shows the idea of mechanical oil palm lumber prior to press drying later today. Oil palm wood contains a lot of sugars and starch. Rabia Dirkes will present in 15 minutes in room C the biotechnological potential of pressed oil palm trunk sap. Andreas Kisselbach from Leitz will answer the question how to process oil palm wood of the high ash and silica content in the next presentation. Next slide. In the past 35 years, the macromechanical properties of all palm wood have been widely studied. Because of the property gradient within the cross-section and the height of the trunk, almost all investigations on properties of all palm wood were performed on small clear test specimens. Most literature deals with the bending strength and stiffness and the strength parallel to the vascular bundles, but not the Young's modulus. This is mainly because of the easy preparation and test specimen and test procedures. The literature is on the systematic and comprehensive determination of the elasto-mechanical properties of all palm wood, depending on its density and location within the trunk, which is indispensable for product optimization and modeling. In the context of two research projects, the elasto-mechanical properties of all palm wood were widely systematically tested on small size test specimens, modulus of elasticity and modulus of rupture and bending, Young's modulus and strength and tension and compression, torsional strength, shear strength, torsional screw withdrawal and embedment strength, thermal conductivity and heat storage capacity. Due to the time limit today, I will concentrate on the tension, compression and bending properties parallel to the vascular bundles, but all results will be published soon. Next slide. Sorry, the slide has gone. Perhaps you can show the next slide until I continue, because we imported one palm trunks frozen to Germany and processed them to small test specimen representing all the trunk. But perhaps you can share my presentation.
Munir, the slide, can you check again? The slide is
The slide is gone.
There's some error is there.
Yeah.
Yeah.
Yeah, and then the next slide, please.
Next slide, next slide.
Yeah. Already had the material. Next slide. Thanks. All the elastic properties. Sorry, one slide back. Thanks. All the elastic.
Back.
Oh, this is correct. Yeah.
Mm.
All the elastic. No, one back. This one. Thanks. All the elastic and mechanical properties correlate with the density. This depends primarily on the age of the palm tree, the location within the trunk, the cross-section and height, and the size, number, and structure of vascular bundles, respectively the fiber caps. The strength and stiffness values are increasing with the density by power law relationships. The relationship is different exponents from softwoods and hardwoods. This is anatomical structure. Like for most long fiber reinforced composites, the Young's modulus and strength and tension parallel to the vascular bundles is high and depends on the density and the properties of the vascular bundles. Like for many fiber reinforced composite materials, the stress strain behavior test parallel is linear from zero load to the ultimate or fractional load. This is typical for wood and tension as well. All failures were due to an angle between the vascular bundles and the direction of the applied tensile stress. The macroscopic fracture patterns differ significantly from those for softwoods and hardwoods or bamboo. The angle between the direction of the applied tensile stress results in two low strength values. Because of the helical orientation of the bundles with deviations in radial directions, it is not possible to process tensile test specimen with perfectly aligned vascular bundles along the axis of the test specimen. Next slide. Next slide, please.
We need next slide.
Not stopping the presentation.
I don't know. It's, when you click on the next slide, it's gone. Yeah, next one after this.
Thanks. The left diagram shows that the tensile strength parallel to the vascular bundles on the y-axis is strongly related to the Young's modulus on the x-axis. This indicates that the tensile can be predicted from a known Young's modulus, which can be used for strength grading in the other presentation. In the diagram on the right, the specific strength on the y-axis and the specific Young's modulus on the x-axis are considered in terms of structural performance. Next slide. Comparable to the tension test, the compression strengths in the diagram on the left and the Young's modulus in the diagram on the right are increasing with increasing the power law equation. Next slide. The stress-strain behavior of the compression test parallel linear from zero load to the ultimate or fracture load with brittle rupture. This is typical for fiber reinforcements and very different from common wood species with ductile behavior and no fracture. The vascular bundles are buckling. The buckling failure of the individual vascular bundles could be heard and is afterwards microscopically and in a 3D reconstruction. This is because the parenchyma next to the fibers are too weak to stabilize the bundles. This line with the literature for composite materials, Modulus Metrics. In addition to fiber buckling being caused by mechanical compressive loads, fiber buckling might be caused as well by shrinkage stresses developed drying, which result from the matrix having efficient of expansion than the fibers. Right? Species, all relationships between strength and stiffness, the absolute on the left and the specific on the right. This is caused statistically mainly due to the very large range of property values of oil compared to common wood species. Next slide. All strengths are increasing the density by power law relationships with similar exponents. These are from softwoods and hardwoods. This might be anatomical structures. Dicotyledons consist of a honeycomb-like structure of tracheids, the softwoods, or fiber cells, the hardwoods, while palm tissues are made up of vascular bundles having honeycomb-like prismatic cells and dense lines along the stem surrounded by ground tissue, made up of thin-walled polyhedral like closed cell form-like structure. Have a more heterogeneous structure in comparison to dicotyledons. Compression, bending, and tensile strengths are in densities. With increasing density, strength is above bending and tension strength. This is different from common wood species. Next slide. In contrast to common wood species, the Young's modulus is above the bending MOE and above Young's modulus in compression. Next slide. Because of the power law relationship between the Young's modulus and the density, for a minimum weight design by Ashby calculated for all palm wood are rising with the density. The specific strength M4 of all palm wood is lower than the values for small clear wood test specimens, but in the range of structural size softwood lamellas. The specific modulus M1 and tension are in the lower range of common wood species for high density or wood. Next slide. Conclusion. The materials of palm wood are challenging, but good for many uses. Therefore, the products need some redesign. Performance indices for minimum weight design by Ashby favor panel products from oil palm wood. Like the compaction behavior at the solid wood production need to be clarified in terms of engineering. Because of the influence of trunk height on the proper lower 5 to 6 meters should be used for solid wood base. Because of the property gradient within the cross section, the lumber should be longitudinally in dense homogeneous stripes, graded and reassembled to products, which I show later in the presentation today. The properties of larger glued structural members are expected to be similar to small specimens. the properties of oil palm GLT will be shown by my colleague Lena Heister later. Next slide. If anyone is interested in news literature, please send me an email. And the next slide. Next slide. Many thanks for listening and sorry for the technical problem. And
it's okay that at least with the technical error, even though you cannot take more time, you know.
Okay, thank you, Katja, for the presentation, giving us an insight from an engineering point of view into oil palm wood. And as we are behind the time, first my apologies go to all the members in the auditorium for the technical problems. We will do our best together with Dr. Javait and the technical assistant that we have a better technical communication later today. Maybe one question, Katja, from my point of view. So if we know enough one day about the material, do you see a chance that we use oil palm wood in the same way, principally in the same way as we do with, for example, softwoods today, as a building material?
Depends on which part of the trunk, and if you do some modification. And we need much more information on the piece of oil palm wood. If you compare it with softwood or hardwood, for example, so we have the same discussion in Europe. We are using for construction timber softwoods for several hundred years. We have a lot of knowledge about. We have little knowledge using hardwoods, and we have, compared to that, we have almost no knowledge on the properties of oil palm wood. So we need more knowledge to produce on the properties to produce construction or load-bearing material or beams or panels with defined elasto-mechanical properties, because for these, the elasto-mechanical properties are more important if you compare it with furniture panels, for example. But I think it's possible, but it research.
Okay.
Thank you so
Because
much.
if I can add, because the properties are different, so it's not a wood. It's a long fiber reinforced, behaves different from other wood species. So we have to learn, see the learning step.
Okay, Dr. Javait, there is one question in the chat. Should we allow this question or not?
Yes, of course, the chair can ask the question. That's
okay,
the thing.
There's a question on how would you suggest to use 5 to 6 meters of OPT as solid wood product, since from your presentation it says that 5 meters is more or less like only 7 years old tree. Maybe there's some misunderstanding. So you recommend, what do you recommend?
I recommend to use the lower part, so the lower of 5 to 6 meters, because these are the older parts, and not to use the top moment, because the top is younger and therefore has different properties. Even the density is not so low. Properties are compared to the density much lower because the cells are younger and there is no cell wall thickening, what we say. So they have to get older, that they have better properties. So that if you have high or material from the top of the trunk, density is not the grading parameter, which I will show this afternoon.
Okay. So
no, we are getting late, so you have to call the next.
Yes, thank you very much for this answer, and we can follow your afternoon presentation then to get some more information.
Yeah.
Okay, now we come to the next presentation. The next presenter is Andreas Kisselbach from Lights Company. Mr. Kisselbach is director for R&D with Lights